video reminder.
I forgot I was writing down the notes.
I know. It's not your responsibility, honey. I'm just busting you. It's my responsibility. But again, so like I was just saying, if you guys remember, inches to feet, we divide by 12. Feet back to inches, we multiply by 12. Okay, so that's your basic inch to foot conversion. We're going to talk about inches into millimeters. Okay, and like I said, we'll get into some of the other more tricky ones there. Okay, let me pause this for a quick sec. You guys understand what this one here is saying when it says inches to mils? For every 1 inch, it equals 25.4 millimeters. And like I said, if I had the tape measure that I really was looking for, it would have shown you side by side, right? That 1 inch, right, would end up equaling the same as the 25.4. By the way, this is set out as, there's my 25, right? These are in tenths, right? So that's 10 mils, 20 mils, 30 mils, 40 mils, 50 mils, 60 mils, and so on, right? Because this is set out in centimeters. Does that make sense so far?
Yep.
Okay, yeah. They have it set up in centimeters, and then to convert from centimeters into meters, you just add that 0 to it, right? It's like moving a decimal place over, right? So let's take the 4 right here on our tape measure, right? If I said that that was 4 centimeters, right? If I want to get to mils, I'm adding on a 0.
Oh, wow.
Yep. Okay.
That's simple.
Yeah, pretty much, right? If I was to say, okay, I want, and this is where, again, it's another one of these ones that works in my brain, and I find it difficult to transfer over. But let's say,
Is it for 1 centimeter? It's 10 millimeters.
yes, yes, and it might have been on that sheet even. Let me see. Yes, okay. So again, if you still have access to your convert feet inches to decimal feet PDF, it actually has that right on there. Again, I wish I knew a way to convert back and forth between these screens a little quicker. So this one here.
Are you able to split the screen?
I know I can do it with my here, actually, I'm going to see what I can do here. Let's see if I can print this. I know I can do it with the hover cam. Ooh, you know what? Yeah, hang on, Mike. Let me see what I can do here. Oh, nope, that's not what I wanted to do. Hang on, let me put this baby on pause for. You're still going to be, the video's going to still be staring at the overhead cam, but you can at least hear me explaining this one. All right, so again, like you said, Poku, 1 centimeter equals 10 millimeters. Okay, 100 centimeters is 1 meter, and 1,000 millimeters is 1 meter. Okay, so this is why they say the metric is a lot easier, because it's essentially just adding on more zeros. Right? Okay. So keeping that in mind, let me get back to this one here. La la la. Okay. There we go. We're still recording. So let me write that one down just to keep in mind here. 1 centimeter equals 10 mils. Okay? So there's how we jump in. If I was to have the metric tape measure out again, and I said I gave it to you as 20 centimeters, that's going to be how many mils?
200.
Yep, 200 mils. Right, so essentially we're just tacking on that extra 0. Okay? So here's where it's kind of interesting. If I kept this into centimeters and I wanted to choose something in here, right, I would say this is 20.5 centimeters. Okay, so that half mark there, let me see if I can bring that in a bit more. Did you guys see where I put my little scribble?
Yeah.
Right?
So it's 250?
Yeah, so if I was to turn that to mils, right, it would be, yes, 250 mils. Okay? Because they break it down, the tickies here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or 210 mils. Okay, so again...
Are you recording?
Am I? Yes, yes I am. Thanks, hon. No, good catch. So let me write that down here. So if I put 21.5 centimeters, what does that equal in mils? Right, so and essentially here it is on the tape, right? 21. Jesus. Alexa, stop. I got to remember to get rid of that. 21.5 is essentially 21 or 210, 11, 12, 13, 14, 15, right? 215. Or sorry, yeah, 215. Does that make sense?
Yeah.
Yeah, because again, remember, I'm just moving that over that 1 decimal place. Just as we did over here, right? I moved that decimal place over to create the 40. Same thing here, my decimal place is here. I move it over 1 to add that 0 in there. Right?
So you would read that as 200, what was the number you read it as?
215 centimeters.
215 centimeters. Okay.
Yeah, because when we start getting into these big guys up here, right, we would read...
Millimeters, you mean, right?
Yeah, sorry, yeah, mils. Sorry, my bad. Sorry, honey. Yes, thank you. 215 mils. When we start getting into these triple numbers here, like 110, right, 110 centimeters will equal 110, add 1 more, right, 1100 mils. If I was to give you, let's say, just because we're sitting at the 10.6 centimeters, right, and if I looked at my tape, 110.6 centimeters, that essentially gets us, now you guys can't see it as clearly as what I'm showing, just past the bigger mark here, right? Yeah, 110.6 centimeters is actually going to be, what did we say? So move that over, we got 11.6, yeah, exactly, mils. But do you guys see how this could be more accurate than trying to use the imperial? Right? This is why doing a lot of, say, cabinetry and stuff where you really need to bring it down to what they tend to say dead nuts, right? Metric is a little more precise. Because here, even with this one, I've got it down to the 16th. you guys can easily read my tickies now versus the tickies on that metric, right? This isn't quite as accurate. Close enough for most part, right? But one of these, the space in between these 16ths, essentially is almost the width of an average saw blade, anywhere from about a 16th to about an 1/8 width, right? But just so you guys can realize the accuracy when you get into those mills. How are we doing so far?
Excelente.
Everybody's feeling okay? I haven't kind of steered anybody down the wrong path, or nobody's kind of going, what the hell is she talking about today? What kind of crazy crap she taking us on today? Let's try. I'm just going to look at the tape and find you something else. All right. $132 centimeters would equal how many mils? 1320, right? Again, if I was to say, let's go with 136.8 centimeters equals how many mils?
1368 millimeters.
You got it. 1368 millimeters. So these conversions are going pretty good, yeah? Okay, good. I don't think we need to linger too long on that. Again, as long as you can remember 1 centimeter equals 10 mils, you'll be good, right? And again, keep a hold of that sheet that I had handed out, because all of these common conversions are on that PDF that you guys already have, okay? I want to get into, let's convert some of the inches to mils, and then I'll start working on square footage and so on and so forth. Okay?
Yep.
So, again, like I said, we already established that metric is a little more accurate, right? So if we wanted to convert our inches into our mils just for accuracy or even for mathematical reasons, right? Like I said, this is the number to remember. 25.4, not 25.5, but 25.4. They're very, very adamant about that. So 1 inch equals 25.4. What about if I said 2 inches? What would that equal?
50.8.
50.8. 50.8 mils. All right. So what we did there was we just went 2 times 25.4. That's where we got our 50.8 mils. Whoops, sorry. There you go. All right. If I had a number in mils and needed to convert it back to inches, what would I then do?
To divide them.
Exactly, exactly. It's kind of like when we're bouncing back and forth between inches and feet, right? Same kind of idea here. So if I was to say 50.8 divided by 25.4, it gives us that 2 inches again. Okay, so let me give you another one. I think I had something here. Doody-doo. Let's try. Oh, I don't have them readily available for you. Sorry, guys. Screw it. I'm going to give you one. How about... Oh, bugger. 25 inches will equal how many mils?
25 inches.
right? Remember, inches to mils, we multiply.
63.
Yeah, I heard a few. Yep, 635. Yeah, 635 mils. Just out of curiosity.
So what are
Yep.
you multiplying to get that?
So I'm multiplying the inches, yes, by 25.4.
Oh, so the inches by the standard rate.
Yes, yes, and that's just it. I like how you said that, Poku. This is a standard number. Just like the 12 is a standard number. Yeah, that's why I was saying this.
They just say it's 25.
Pardon me?
I said I think the states they just say it's 25 millimeters. If they had to say it, I think they always try to round it down, which is why it's not as accurate.
Yeah, they're the states, right? America. We're a little better here, and we add that 0.4. America. But yeah, no, I have heard that, Gary. But yeah, the 0.4 just gets you more accurate. That's funny because that's why I sometimes say, in working at heights, converting back and forth between the metric and so on, I usually say the height of a guardrail is anywhere from about 36 to about 42, 43, depending on how you convert. But we, as good little Canadians, we add that 0.4 in there. Right. But yeah, so Poku, that's a standard. That's why I was saying on my favorite calculator, as dorky as that sounds, I do have a favorite calculator, and I actually have that permanently affixed to the back of my calculator just for memory. So down here, hun, right, we just took the inches and multiplied it, right? So 25 times 25.4, and we get that 635. Did you try that out, Poku?
Yeah, I'm doing it right now.
Yeah. Good. And just, again, just for shits and giggles, what would this be in centimeters? Anyone want to give that one a shot? 635 mils would be what?
Divide by 25.4.
Yeah, you divide it. Oh, no. Sorry. Mils to centimeters. Metric to metric. Right, so mils.
So you would divide that by 10?
Yes. Right. Essentially, we'd just be moving that decimal point over 1 to call it 63.5. Right. I just messed that up by throwing decimals in the way there. Right. Yeah. Yeah, but you're right there, Poku, right? Just like we've been doing with some of the other things. Centimeters to mils, mils to centimeters. Right? Times by 10, divide by 10. Okay, how about, let's try, let's do 36 inches into mils.
Okay, so it's 36 multiplied by 25.4. Did you know? 36.
$965.
What'd you get?
Is it 965? 965.
Mils?
Is it 914?
Small.
I got 914.4.
Oh, yeah.
Oh yeah. My
Yeah.
bad.
That's okay. 914.4 mils. And then what would that be in centimeters?
9144.
Yes, you guys. 91.44 centimeters. Because you could have either taken this mils, divided it by 10, or just take that decimal point and move it to the left one. Okay.
So what did you say? We could divide it?
Yeah. Yeah, because
Or
remember,
multiply?
divide 914.4 by 10, and you get the 91.4. Right? Because again, if you remember Poku from up here, right?
Okay.
Yep. Again, it's just like when we were bouncing back and forth. One way is going to multiply it will get you your mils. Dividing will get you into your centimeters. Right? Over here, multiplying by 25.4 will get you your mils. If we divide by 25.4 from our mils, we get our inches. And let's actually try that. Let me give you one in inches. Or sorry, in mils. And you convert it into the inches. Let's go, just because it popped up real quick, I'm going to say, let's go 40 mils into inches. I actually don't know what that's going to be, but let's see. So remember, mils into inches, we now divide by 25.4. Right? So 40 mils divided by 25.4 gives us 1.57, I'm going to say 48, and that's where I'm going to stop. It goes 0.315, but that's how many inches. But I can't exactly, so it's just over 1.5 inches. Just for the sake of doing this, minus 1 times by 16. Yeah. So
65.
yeah, this essentially works out to 9/16 roughly. Right, which is just over 1/2 inch. Right, so you guys remember how I did that? So I dropped the full.
I forgot to convert. I forgot to convert the decimal into a fraction. That one, it always messes me up.
Okay, so and that's what I just did there, right? But you guys, so right away I knew it was going to be just over 1/2 inch or over 1.5 because of that 0.5 something something something.
Yeah.
Right, but do you remember how we do that? So this 1.5748 inches, I dropped the whole inch, then I was just dealing with the 0.5748, I think it was 0.3 something something something. So I took that decimal inch and I actually multiplied it by 16 because that was the lowest set of tickies on my imperial tape measure. Right, so go here, I'll show you what I did. I'll show you in the calculator here. Let me try and get a nice view for you. So I went 40 millimeters divided by 25.4. It got me the 1.5 something something, right? So that was my inches, but decimal inches.
Yeah.
I want to turn it into inches and fractions. I'm just going to get rid of the whole number. So I'm left with just the fraction again. And like I said, I was using the smallest set of tickies on my tape measure, which is 16ths. So I multiply that decimal by 16 to get me 9.19. So it's still just basically 9/16.
Okay.
Okay?
Got it. Yeah.
Yeah.
These things, because I don't remember them, so I usually messes it.
Yeah.
So now it's clear.
Good. And are you guys finding it helpful by me showing you how I'm entering it in the calculator as well?
Yeah.
Okay, good, good. Right? Because again, this is hard to yell out to somebody on a tape measure, right? Especially if I say 1.5 plus. Actually, funny enough, that's how I would have yelled this out to somebody on a job site. My cousin and I used to work together, and we had our own little vernacular, I guess, that instead of saying 1 9/16, I would basically holler out 1.5 plus. Because it essentially meant, give me, woo, dang it, 1.5, so 9/16 would actually be this ticky right here, right? Because there's 16 of these tickies all together. There's 8, or 1/2, plus 9 tickies, or plus 1 more. So this is where I would have said, hey Kyle, can you cut me something at 1.5 plus? So he knows when I say plus, just add on 1 more 16th. I hope I didn't confuse anybody.
You know how I put it? I put it 1.5 plus 1/16.
Yeah. But like I mean, that's kind of a funny way, but you're not wrong, right?
I find that when I do the measurements for the journeymen ask me to do it, right?
Yeah.
So I want to be quick. I want to be very quick. I just say, okay, 1.5 plus 1/16. That should be the one.
Yeah, so it's the same as when I holler out, and sometimes I'll even, if I'm having to write stuff down for my partner that I'm working with, again, my cousin and I, like I said, we had a vernacular with each other. If I had to write some cut measurements down, instead of saying something like this, I might have even wrote down 1.5, and I would have went plus. He knows ahead, or you might hear someone say, give me 1.5 heavy. Right?
Oh.
Yeah.
That I would not understand.
Yeah, that's...
I understand.
Yeah. Well, that's... And again, this is just, vernacular you might, or wording you might hear on a job site. Because I've heard that before, too. 1.5 heavy. My dad, if he was trying to say, just under 1.5, so... Again, here would be one that would be tough to read out. Like if I'm going 1.5. Yeah, like instead of saying, cut me 1 7/16, that's just something you don't holler out too much. I might have said, or rather my dad would say, cut me 1.5, take the line, which means I'm basically 1.5 light. And again, I'm just sort of giving you guys some little things you might hear out and about. Right? But that's something he always taught me was, take the line, leave the line would mean heavy or light. Right? Pluses for me always meant add that 16th on, like you were saying there, Renee.
Yeah.
Right?
Yeah, because I said, instead of going and counting all the ticky, it took a long time.
Yes.
So, and then without, I forgot to bring my glasses. I said, okay, 1.5 plus 1/16, that's done.
Yeah.
So, or I put a plus sign, so I know just going over just one little ticky, but I don't know, because at that time my mind is not counting. I just reading whatever the tape measuring tell me to. Yes.
Yeah. Because it just, and this is just the experience that I've had, a lot of times they try and keep it to the measurements that are quickly readable on a tape. So kind of like you were saying there, Renee, it's quick to find 1.5. I can quickly find that.
Or 1.25.
Yep.
3/4. Those are the number that are very quick, right? But
yep.
The small ticky that you have to count them, and especially you're not using it all the time, so and you have to count them all the time. I said, forget it.
Yep.
Just look at 1/4, either plus sign or exactly where it is.
Yes. Yeah. Like essentially, so anything higher than 1/16, and I would call it out as the 8th. So I would keep it as, so for the 9 and 16th, I would say 1.5 heavy. But if I had one more ticky, then I would just go right to 1 and 5/8.
Yeah.
Because again,
5/8, 2/8, 3/8, 4/8. Those easier to know.
yeah.
But a small little tiki, it's especially unless you have a really big tape, like a small tape is really daunting on the eyes.
Yes. Yeah. And that's why they tend to do stuff like that, right?
Yeah.
Yeah. And especially when it comes into a lot of the more rough carpentry and things like that, where they'll allow variances, right?
Yeah.
And just saying heavy or light can kind of get away. I hope that helped a little bit there, that little bit of, I guess,
very much.
yeah, job vocabulary, I suppose. Let's try another mill. Let me give you, how about, let's go, I'm just pulling numbers out of my head right now. I don't know what they're going to look like just yet. So 135 mils into inches. So now remember, we're going mils to inches, we're going to divide by 25.4. Yeah. Oh, I'm going to pause this first.
Yeah, I found when you teach, I understand. So I actually like math now.
That's
I like
awesome. I like that. I like hearing that.
Yeah, before when I look at the math and then other student, it looks like so simple. Everybody finished. How come I still struggle? It's because of that one step that I cannot get through it, and it's just a stumbling block. And then now it's been demystified. So
Yeah. Oh, I like that. Demystified.
yeah.
But that's where I used to be at, Renee. Like, I hated math. It was my worst subject all the time. Right? Even when I was getting things right, like answers to stuff, I would get them right. I'm like, but I don't understand. I don't understand how I got it right. Right? So it never was really enjoyable. But as soon as things started to click, yeah, all of a sudden I was like, I enjoy math.
Yeah.
Yeah. It's definitely, and again, Pat and I were just talking about this because he was doing some decimal feet conversion stuff, I guess, today with his formwork folks. And I think I already told you guys, Pat is fantastic with math. I mean, the math he can do in his head and how quickly he can do it amazes me. But that's where he was like, wow, what a difference. To be knowledgeable in math, but then to be able to break it down for people. He's like, it's a skill.
Yeah.
It is.
Yeah. Like, he gave an answer to somebody. Oh yeah, they were multiplying decimals, right? And remember how when we're multiplying decimals, if both numbers have a decimal and some numbers behind it, remember how we have to add those numbers together, and however numbers are behind the decimal is how many are supposed to be in the answer. He kind of already knew this, and a student kind of said something, well, how did you know where to put the decimal point? And just because he knew it, he's like, that's just where it goes. And I was like, ooh. Another student piped in, though, and kind of explained that. but that's where Pat kind of went, yeah, see, that's where I didn't remember how to break it down. My brain automatically knew to put it here.
Yeah.
Right? So, yeah, it's definitely something different when you try and anybody with children, I'm sure you probably have kind of run into, oh, I know how to do this. I just don't know how to tell my child how to do it.
Yeah.
Right? So, yeah. Hey, what did anybody get for 135 mils into inches? What'd you get?
I got 5 and then 5/16.
Yes, that's what I got too. Right, and I'll work it out. Right, so the answer that I got was actually 5.314, and then it went 96063, and I just sort of rounded it to, actually I think I went 5.315. Right, I just rounded it up. Because again, this is what the number actually looked like. 5.314966063. I just kind of took these ones here and rounded it up to 315. So that's our inches. But again, we can't just holler this out to somebody. So I want to convert it into something I can read on my tape. So again, let me use my little red here to divert us down here. I dropped the full inch down, right? And then again, I'm left with what's happening here. Okay, so 0.315 times, and again, I went for the smallest set of tickies, and I multiplied that by 16 to essentially get 5/16, and I'll show you what I mean by that. 5/16 inches. Okay, I'll put that in my calculator again so you guys can see it on screen. And I'm going to put it into the calculator. So, whoops, let me find somewhere. There we go. So, 135 mils. Mils to inches, we divide, right? By 25.4 equals, there's that 5.3146, so on and so forth. But again, remember that full inch, I'm just going to drop it down. There it is there. And I'm going to get it out of my calculator. Minus 5, the whole number. I'm left still with that. Yep. And again, like I said, I chose the smallest increments on my tape measure. So that decimals times the small increment, 16, and I get 5.039. Essentially, it's still just 5. 5/16. And that one I can holler out. Or again, I can either say, cut me something 5 5/16, or I can say, cut me 5 1/4 heavy. Does that make sense?
Yep.
Makes sense, yeah.
Yeah. Again, it's just that vernacular. Right? Because, like you were saying, Renee, something that you can quickly, instead of sitting counting tickies, if I say 5 1/4 heavy, you're not sitting there going, what's, 5, 1, 2, 3,
No.
right? Yeah, I find my 5 1/4 heavy.
Yeah. And then just go one tick over.
Exactly, right? But that's something too that if you're on a job site, and someone is hollering out measurements, just kind of get on the same page with each other. Hey, instead of hollering out 16ths, I'm just going to say 5 1/4 heavy, right? This is the way I was taught. Heavy means one ticky or 1/16. Okay. It also just shows a little bit more, I don't want to say advanced, but maybe confidence with reading your tape measures.
Yeah.
Okay, it sounds a little, I guess, more professional, or like you've been around the block once or twice.
Yeah. I actually stumbling into it. I did not know the industry used this kind of language, but then the journeyman was asking me to do the measurements, so I said, I can't be slow like that. So I have it to do in such a way, and then plus, I don't have my reading glass at the moment. I just do whatever that necessary need to be done, but have to be very accurate. So that's what I did. I said, okay, now 3/4 plus,
Yeah.
or 3/4 minus.
Yes.
And that I know exactly where to do it in a tape measure.
Yes.
Tape, so, yeah.
Yep. And that's just it. You get to know how everybody calls it. Like I said, plus or minus. In my dad's case, take the line, leave the line, that kind of stuff. Heavy and all that sort of stuff. So again, going with what we're talking about with you, Renee, 5 5/16, I'd say 5 1/4 plus or 1/4 heavy.
Yeah.
All right.
Yeah. Yeah.
Mm-hmm. Cool. This is seeming okay. How's everybody else grasping this?
Getting there.
Getting there?
Easy.
Easy peasy. I would hope so, mister.
I don't answer too often because I don't want to just jump all over it. So I like to give everybody else a chance.
Yeah,
So
yeah.
my silence is not because I don't know it, just because I'm just trying to let everybody else have it.
Oh yeah, no, Gary, I know your resume, so I would hope some of this is pretty okay still. But again, hun, if there is anything that you were like, oh shit, I forgot about that, right? That's what we're here for too, because there's stuff that I've completely forgotten about until I've had to kind of look through my books because, oh crap, I got to show you guys this. Right? You don't use it, sometimes you lose it.
Yep.
Right? Definitely, especially if you haven't had to do this kind of math, because we have calculators on our phones nowadays. Shoot, you can type in an equation into Google and it gives you the answer for you.
Yep.
Right? But it's always a good idea to be able to do this stuff just in case you don't have the ability to use your electronics. All right. Let's see. All right, let me give you one more mils to inches, and I'm going to give you something. Let me give you something heavier. I want something into the big numbers. Yeah, whatever. I'll give you this one. Let's just go with another 3-digit. 560 mils into inches. Okay, again, remember we're dividing by 25.4. Ooh. Okay, I like this one because I'm going to have to explain something a little bit there too. Ooh, I'm going to
To answer, I don't know which one is better.
Okay, what did you get?
I have, I don't know if it's 22 and a half or 23 and a half.
Okay, I liked the 22, but I wouldn't have gone with the half.
Oh, okay. Because I reduced, 8/16. I reduced that to half.
Okay, so I think I know what you did there. So let me run through this one, because what I got, and who knows, I could have an off day, but all in all, I got, let me write it in my full thing here, 22 and a 16th is what I got, and I'll show you how I got there. Okay, so essentially I went, right, so 560, and I'll do it in the calculator together. Right. So 560 mils divided by 25.4, and we got 22.04724. I think, Renee, you might have missed the 0.
Oh, yeah, I did.
Mm-hmm.
I did. I missed the 0.
Mm-hmm. Yeah, no worries, right? So, and here's what I did after that. So, again, this is my inches, right? But I have it now in decimal inches. But the 22 is my full, right? So I'm going to drop that 22 down, right? Just like I have there. I'm going to get rid of it in my calculator, right? Get rid of that whole number, minus 22.
Yeah.
So I'm just left with the 0.0472 blah, blah, blah.
Right.
Again, I'm going to go with the 16th just because it's the smallest on my tape measure. So multiply by 16.
Yeah.
And I get 0.7. So it hasn't quite got to that full inch, but we technically will round it up.
Oh, you round it up to 8?
To the 1.
Or
right?
to the 1?
Yeah, because I'm just looking at the number directly to the right of the decimal point.
Yeah.
It's over 5.
Yeah. So
Right?
it's 8.
So, no, sorry, honey, right here.
It's 0.8.
Yeah.
She's not wrong. It's just, I know what she's saying.
Yeah. So, yeah, you're not...
It's this whole number.
Yeah, I want it. There you go. That's the better way. Thank you, Gary. That's the better way of saying it. I need the closest whole number.
Ah.
Yeah.
Okay.
So the closest whole number.
Super small.
Yeah, exactly. And this is why I was kind of like, ooh, this one could kind of show you why the mils is a little better. Because I just rounded up to a whole 16th.
Okay.
The actual measurement isn't quite that 16th. It would probably be something closer to in the 30 seconds. Right? So essentially what that's saying is, now I could take us right up to the 22. So essentially what that was telling us by what was in the calculator is it's 22 and less than one of these. So it's not quite to there, right, by it saying 0.75. But if I need a whole number, right, 16th is the lowest one on my tape.
Okay.
So do you see how it's not quite as accurate unless I had a tape measure that brought me down into the 30 seconds? Like, let me actually see what that would end up being.
Are you able to multiply by 30 seconds?
Sure. Yeah, that's what I was actually going to do right here. So let me get that back in. 560 divided by 25.4 equals the 22.04 blah, blah, blah. Get rid of that 22 because that is my whole inch. Now I'm left with that number again. Instead of the 16th, let's say I've got a tape measure that had the 30 seconds times 30 seconds. There you go. Now I've got something closer to like 1.5 to 2 30 seconds, which essentially happens to be
1/16.
Yeah. But again, I'm still sitting sort of in between, right?
Yeah, in between.
Yeah. And this is again why I say the mils are more accurate. right? Because again, look at how many increments are now on there.
Yeah, that's a lot of increment.
Yeah, but it is more accurate that we can get that
sit
down.
there and count forever, and then
Yeah.
and the eye cannot do all these like.
Yeah, it definitely can be a little bit more. Yeah, you got to get in there with your magnifier.
Yeah. So,
Don't worry, Renee.
which I'm not gonna do.
What were you saying there, Gary?
I was saying, don't worry. Most places that you work at, the tolerance is an eighth.
Yes.
8, eh?
So if you're off by
Okay.
a 16th, you're
16 is more accurate.
going to scrutinize you.
Yeah, exactly. Right. Now, if you're an engineer or doing, some other things where it's like they get it down to some crazy decimal of a mil and so on and so forth. Yeah, that's an increment of, or a variance of an eighth or a 16th is a big deal. And who was it? Poku, I think you were kind of making a comment a few lessons ago that even a 16th could mean a cabinet door rubbing or not. Right? So, yeah, it just depends on, like Gary was saying, what you're doing and what they've allowed for your discrepancy or variance. And sometimes they'll allow
I did
it.
say that. Sorry, I did say that.
Yeah.
I did say that.
No worries. Yep. So, formwork, that's like your concrete foundations and things like that, where they're making the molds. If you're within an eighth of what they asked for, you're okay. They're not going to, like Gary said, scrutinize you over a 16th. Right? Oh, I want you to get us at this measurement. Well, I'm like a 16th off. They're going to laugh at you. Right? And tell you, oh, screw off. That's fine. Right? Yeah.
Don't forget, engineers have snapped a grid, so they always think there's like no tolerance. They're like, oh, it's supposed to fit perfectly. It's because that's how I designed it.
Yeah. Yeah. They want you to be sliding it in there.
And their wood swells by 6 millimeters. You're like, how can you have a 1 mil tolerance?
Right? Yeah. Oh, yeah. I've had a few of those things happen even here in our home shop where I haven't allowed a variance for any kind of, the swelling. And yeah, I've had some projects kind of get ruined because it was too tight. But anywho, you guys seem to be grasping those okay, yeah?
Yeah.
For the most part. And again, it's just sort of this inches, decimal inches into something you can read on a tape. That's again drawing on some of the previous sessions that we've had. And if it is something that's causing you some issues, look back at some of the ones that we did. Again, I think we've got them on video. And we may play around a little bit later on tonight or on our last day if there's any stuff that you guys wanted to review again.
Yeah, I think this one is a good example because this one is the closest to one, and then you either get it or you don't.
Mm-hmm.
So I'm glad that you're able to explain. So now
Good.
I understand. Yeah.
Good, yeah. And again, it's just a matter of trying a few things out, right? Double checking your answers, right? Like I said, try them on your own, and then to check stuff, Google will give you the answers, right? And and again, that math book that I was telling you guys about, the one that I work out of, that's a really good one.
Oh yeah. I haven't had time to check, but I really want to buy that.
Like I said, I love this book.
Yeah.
I really do. It breaks some things. Some things it breaks down really well. There's a few things that it doesn't break it down. At least it doesn't break it down easy enough for me. It takes me a moment or two to have to go through a few things so that I can put it into a way that I understand. Right? So let me try. So we did basically inches to mils, mils back to inches. We kind of converted back and forth between our feet and inches. We've been pretty much staying in a linear set of measurements, if you know what I mean by that, right? I'm keeping it, how else can I describe linear?
Simple.
Yeah, okay, yeah. I've been keeping it fairly simple. I'm going to go into now talking about the square footage, right? Square feet into square inches. When we're talking about stuff like that, so again, let me write that down. 1 foot squared equals 144 inches squared. Whenever you see something where it's got the little 2 kind of up above, or you might even see it written like this. I've seen people write it like that, square feet or square inches. Okay, it's the same as having that little 2. Okay. Essentially what this is saying is we are doing a length times width. Okay. So we're taking a length times width. Now we're starting to get into where we're calculating, say, rooms. Okay, but we'll get into area, right? So square feet, there we go. That's how we would describe it, is area. Okay, area. So length times width. But we're going to work on the conversion that if we happen to already have our numbers in our square feet, how do we put it back and forth between square inches? Okay, we'll work on calculating area after break, but let's still work on our converting back and forth. So 1 foot squared equals 144 inches squared. Okay, so just like one foot equals 12 inches, right? So essentially it's like saying 1 foot times 1 foot equals 1 square foot. Whereas 12 inches times 12 inches equals 144 square inches. Okay, does this make sense, or have I lost? So again, if I was saying, so there's 1 foot times 1 foot. This inches here. Instead, we're calling it 12 inches. 12 inches. Okay, so length times width. Length times width. Length times width. Okay. So, and we'll get into more of these, but essentially that's what it's saying. For every area of one of these measurements, or even if we were to look at these little squares individually. Okay, so trying to find another way of explaining what that means, how to explain that. Hang on, let me pause this for a quick sec.
Time width, right? You have four at this corner, so in the area is 12 multiplied by 12 multiplied by 12.
Is it area length times width times height?
No, you've added in a third number. When you get in height, we're getting into volume. So maybe this is describing when you've got the 2, it's like a 2D versus 3D.
2D, yeah.
Yeah. Right?
So 2 of the W and 2 of the L.
Mm-hmm.
So that's why you put in square. Is that what it is?
Yeah, so so we're giving so square footage or square inch is our area. So if I was to say one of these, one little square here. So these two are equal. It's just one of them is being read in feet. The other is in inches. Right? But it's telling you that, so the area of this one square, instead of just giving you, say, a perimeter of how many of these squares in line, I'm giving you the area. So if I had to, area is all of this, right?
Yeah.
Right? And maybe I should have taught you area calculations before getting into this conversion. But it's essentially that if I said to you, here, let me give you a number here. 432 square inches would be equal to how many square feet? So that would be, again, kind of like converting back and forth between feet and inches. Instead, now I'm just converting between square feet and inches. So just like we would have gone from, if we were going inches into feet, remember inches into feet is dividing by 12. Right? If I'm going square inches to square feet, I'm now using 144 instead of just 12. Does that make sense? So, okay. Let me keep it simple here. So, 2 square feet equals how many square inches? So I'd essentially be going 2 times 144 would give us our, 288 square inches. Okay. Now, if it's screwing you up just having this 2 here, then just think about just these two numbers, right? Okay, again, just like we were saying, just like we were saying over here, we're playing with 12. Over here, when it's back and forth, we're playing with 144. Because it's, instead of just a linear inch, we're dealing with this. Okay, so feet to inches would be more or less if I'm measuring, say, something length, right? Or perimeters. So, or if I'm measuring the length of the board, that's what I mean by linear. When I'm now trying to figure out, say, how many, think about it this way. Oh my God, I'm so sorry, guys.
Oh, you're doing
Don't
great.
worry.
Okay.
Yeah, we're learning.
Okay. So what if I brought it down into thinking about sheets of plywood?
Yeah.
All right. So a sheet of plywood is 4 feet by 8 feet, generally, a standard size sheet of plywood, right? And I had a room, right, that measured something like 16 feet by 16 feet. Let's just call it that. 16 feet by 16 feet. I want to know how many sheets of plywood would go in there. That's where square footage comes into play, in a sense. I might have screwed you up there. But essentially this is area. If each one of these is, say, a sheet of a sheet of plywood, right? It's how many sheets of plywood would I need to cover this area? Right?
Around 64.
Is that what it is? I didn't mark it out. But yeah, so 4, I would have 4 sheets, 8 sheets of plywood, I think. 1, 2, 3, 4, 1, 2, 3, 4. Yeah. I'll get into that. I might have just screwed you up a bit there in trying to figure out how to describe that, but
Oh, it's 16. I thought you said 60.
sorry, hun. Yeah, 16.
No, yeah.
Right? So, yeah. 4 feet. I can get 4 of those this way. 8 feet this way. I can get essentially going like this, right? So 1, yeah. Oh my God, I didn't even measure that, count that out. It kind of just worked for me. Right? There's 1 sheet of plywood, 4 feet, 4 feet, 4 feet, 4 feet, 8 feet, 8 feet.
Oh yeah. Yeah, it does look like it works out this way.
Mm-hmm. Yeah, I didn't measure that. But essentially when we're talking area, that's what it's saying, is how many square feet can go into the inches, right? But again, when it comes to converting, right, it's just like doing this back and forth, but instead of using 12, because I'm not linear, I'm using an area, right? This becomes 144 inches. Right, so we're not dealing with just 12 back and forth. So let's try this one then, right? Just using the known, or let me say it how you said, Poku. This is the standard. The standard when you're converting square feet to square inches and back and forth. Just like feet to inches, 12 is the standard. Just like back here with mils and inches, 25.4 is a standard. Okay, so if we think about 144 is our standard square inches, right? We're just going to treat it as if we were bouncing back and forth. And let me explain that down here. So 432 square inches, right? And I'm just going to leave out the 2 for now, right? But do remember that we're playing with the 144 right now.
Yeah.
Okay? So if I want to take inches, square inches, and I want to convert it into feet, square feet. Inches to feet, right? Remember, normally inches to feet we divide. Does that make sense?
Yeah.
Right? So this time we go 432 inches, square inches, divided by what we're using, which is 144, should equal, I believe it's 3 feet. Divided by 144 equals 3. And that's 3 feet squared. Right? Because the 144 is what we use when we're converting back and forth between our square inches. I do apologize that I can't find the words to describe this, other than just realizing again that 144 is a standard conversion back and forth. Right? Just like this was a standard conversion between plane or linear feet to linear inches. We're getting into area, which is now our 2D, right? If that makes sense. Versus when we get into volume, volume would be like 3D, because now we have, instead of just this flat area, I now have something 3D.
I don't think you're recording it.
Yes, you are.
I think so. Yep. It just when it gets
Sorry, I
past.
didn't see it properly.
That's okay. I prefer you to remind me because I tend to forget, and every once in a while I have to look over. Because once it gets past like the hour, there you go. Yeah, you don't see the minutes ticking unless I press on it. All right. So volume is 3D. Area is 2D. After break, why don't we get into the area and volume, and maybe this might make a little bit more sense.
Yep.
Okay? So yeah, let's go for break. Let's do, again, 45 minutes, if that's okay with anybody. We're going to have a little dinner down here.
Yeah.
Okay?
Yep.
Awesome. So I'm going to stop.